What is a vector? Let me start by explaining to you the difference between a scalar and a vector quantity. A scalar is a quantity that has magnitude only. Examples of scalar quantities are things such as temperature, mass, volume, and speed. On the other hand, a vector is a quantity with both magnitude and direction. Examples of vector quantities are velocity, displacement, and any force, including the force of gravity. Now let me show you how we represent vectors. Vectors are represented as directed line segments. And there are a couple different ways to name this vector. We could choose a letter. I'll choose the letter V, and then put a vector symbol above it. Or we could choose a letter for the start of the vector, and the start of the vector we call the tail. I'll choose the letter A for the tail of the vector, and put another letter at where the vector finishes, at the tip of the vector. I'll choose the letter B. And because this vector starts at A and finishes at B, we could define this as the vector A, B, and then put a vector symbol above those two letters. That communicates that we have a vector that starts at A and finishes at B. Now this vector has both a magnitude and a direction. Its magnitude is represented just by the length of this line. And if you put vertical lines around the name of the vector, that means the magnitude of the vector. The direction of this vector is communicated by the arrow that's at the tip of the vector. That shows what direction it's going in. And there are a couple different ways to communicate the magnitude and direction of a vector. Let's say this vector represents a velocity. We could say that the magnitude of this velocity is, let's say, 10 kilometers an hour. And we would have to give it a direction. We could give it a direction based on its quadrant bearing. I could say that it is north, 37 degrees towards east. That means it's moving towards north, but moving 37 degrees towards east. Now this isn't the only way to define both the magnitude and direction of a vector. To describe how to get from the tail to the tip of a vector, we could instead break the vector into its horizontal and vertical components. By doing that, we get a vector in what's called component form, and we call that type of vector a Cartesian or algebraic vector. Let me make up a new vector. I'll call it vector u, so I can show you what component form looks like. Inside of square brackets, I write a horizontal and vertical component of a vector. So the 5 is the horizontal or x component of this vector u, and the 2 is the vertical or y component of this vector. To graph this vector, on a Cartesian grid, I choose a starting point. I'll choose right here at the point 2, 2. And then to get from that point to the tip of the vector, I have to move 5 units in the x or horizontal direction, and then 2 units in the y or vertical direction. And that would bring me to the tip of the vector right there. And then this vector u could be translated anywhere on the Cartesian grid as long as I keep its magnitude and direction the same. So what's commonly done is it's drawn in what's called standard position. And that means it's drawn so that its tail is right at the origin of the Cartesian grid. And we do that because if we look at the coordinates of where the tip of the vector is, it's at the point 5, 2. Notice those coordinates exactly match the x and y components of my vector. And then if I wanted the magnitude of this vector u, if I were to label the horizontal and vertical components of this vector, you would see that what we have here is a right angle triangle. So to find the magnitude of vector u, I know that 5 squared plus 2 squared would equal the magnitude of u squared based on Pythagorean theorem. And if I rearrange that, I would know that the magnitude of u equals the square root of 5 squared plus 2 squared, which is equal to the square root of 29. And it might be useful if I give you a generalized formula for the magnitude of any vector. Let's say we have vector u and we want its magnitude. What we do, based on Pythagorean theorem, is we do the square root of the x component squared plus the y component squared. Let me make up one more vector to try this all out. Let's say we have another vector, I'll call it vector k, and it's the vector -2, -4. To draw this vector, I could draw it in standard position by putting its tail at the origin and making the tip go to the point -2, -4. And then if I wanted the magnitude of this vector, if I follow my magnitude formula, I just have to do the square root of the x component squared plus the y component squared. So that would be the square root of 20, which would simplify to 2 root 5.